hopefully everybody can see my Do You Think MDX is Hard title screen. So if you can't see it, just let me know. Let me get my mouse going here on the right screen. So a little about me. My name is Robert Kane, Microsoft MVP, been one since 2008. I work here at Pragmatic Works as a senior software solutions architect, helping folks out with all the software. Co-authored a couple books, a lot of public speaking. You'll find me online at arcanecode.com, same for my Twitter handle. The one question that everybody always has right off the bat is, are the samples you're going to show today available? And the answer is yes, they are. They're already uploaded to, it's the easy way to get there, bit.ly/SoYouThinkMDX is hard. All one word, no question mark. So should be pretty easy. And I'll put this back up here in just a few minutes before we launch into the main demo section. If you're going to be in the Knoxville area, I'll be at Code Stock. So come on out and see me there. Say hi. I'll also be at the PASS Summit, speaking there, presenting on Zero to Hero with PowerShell and SQL servers. If you want to learn more about PowerShell, if you're not familiar with the SQL PASS organization, it's a great organization. They put on all the SQL Saturdays that you may have attended. Lots of good things. And again, the conference this year, October 27 to 30 in Seattle. So great time to be up there. So MDX stands for multidimensional expressions, and it's a query language that we use to retrieve data from a cube. It is similar to traditional Transact SQL, but totally different. The folks who created MDX thought that, hey, if we make it similar to something people already know, it will, make it easier for them to learn. The problem was it was too close to what people already knew, so they brought their preconceived notions to MDX about the way queries should work, and it really throws people. I think that's the main reason people have so much problems learning MDX, is to try to change that mindset from the way SQL works to the way MDX works. Now, a lot of people think that MDX is this big, scary creature, but, it's really not. It's mostly about location. Now, MDX, you're going to find that you can use this not just with analysis services, but with other cube-based things such as Hyperion Essbase, SSAS OLAP server, and more. And I mentioned we could use it for querying a cube, but you can also create reusable cube components such as calculated members. You can use them to create KPIs, to modify your cube, and even more. As I mentioned, writing LEX statement for MDX, it's all about location, 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 just like real estate. And if we think about, we want to go get a cell out of an Excel spreadsheet. Well, Excel spreadsheets are a little bit like a cube because you've got rows and columns, and then you've also got multiple pages to a spreadsheet. And when you want to reference something, you can simply say, well, I want this column and this row, so I'm creating an address of B2. Likewise, if we've got multiple sheets within our spreadsheet, we then need to extend our reference to indicate what sheet it is. So in this case, I'm going to go to my sales sheet to cell B2. And I'm all about building up a specific address to get a cell or a group of cells. We could extend our analogy to go on. If we wanted to go into 4 dimensions, we could actually give the file name, the worksheet name. We could actually go to 6 dimensions, the drive, the folder, the worksheet, and so forth, and all the way out to however many dimensions we need to actually indicate a unique cell within our spreadsheet. Now, in the world of MDX, these addresses are called tuples or tuples, depending upon which side of the debate you come down on. For whatever reason, this seems to result in heated discussions, but we can either call it tuple or tuple. Both are correct. And you can see here, I'm going to call this a pseudo tuple because this isn't actually a real address, but you can see if I want to reference my little red cell, I need to give it the intersection of my date dimension and my product dimension. So here you can see my Mountain 200 Black at the intersection of 1/1/2008 gives me that specific cell. Now, this is a very important concept to understand, and this is the way that SSAS gets a lot of its power. That is, it pre-stores these totals as cells in my cube. So if I want to find the grand sum for all products and all, SSAS has already stored that for me in my cube. I don't have to calculate it. So because I don't have to calculate it on the fly, SSAS produces a lot of speed. The same for, you can see here my product of Road 250 Blacks. Obviously, this is going against the AdventureWorks database. For those of you not familiar with it, it is a fictional bicycle company database that Microsoft put out. And so the Road 250 Black bicycles for all dates is stored in that green cell. So I have to give it enough information to get that grand total sales across all time for my bikes. The spreadsheet we can extend to 3 dimensions. So here in the front row in the light blue, we are storing our sales amounts. So again, we simply add a 3rd dimension to my tuple in order to get that value. On my second row, I am storing my order quantities. So again, we simply add a 3rd item to our tuple in order to be able to reference that specific cell within our cube. One concept to remember is that with SSAS, what you actually type in is what's called a partial tuple. That simply means that you only need to give it enough information, and then SSAS turns around and says, oh, well, a true tuple is the intersection of all dimensions in my cube. But if I were to try to type in all employees, all territories, if I got 20 dimensions, it's going to take a while. So SSAS helps us out by just assuming, well, if you only entered Mountain 200 Black 1/1/2008, that you also wanted the intersection for all employees, all territories, and the all value for all of your other dimensions that are in your cube. Now, sometimes, when you have a tuple, you're getting the intersection of a single point. But I mentioned earlier that you could actually get multiple values out of our cube. Well, we do that through what is called a set. A set is a collection of items from the same dimension. For example, if I wanted to bring back multiple measures, I would create a set out of those. You can just simply list them: measures.internet sales total, measures.reseller sales total. A tuple is defined using parentheses, but a set is defined using pieces. One more concept that may kind of blow your mind is that measures are a dimension. It's type of dimension, but they are considered a dimension once you get into the cube. So at the cube level, we're just talking dimensions as far as measures are concerned. Now, in order to get a specific value out of a cube, we need to address it properly. And there are 2 ways we can address it. In the first, we're going to list the dimension, and then we're going to list the item within the dimension, in this case, the category attribute. And then, once we've listed the dimension and the attribute, we're going to list the value we want. Now, in our dimension for products, the bikes are the first item inside my cube. It is associated with surrogate key 1. If you actually go into AdventureWorks and you do a select star off the category table, you'll see that bikes has a surrogate key of 1. So we can address either using the surrogate key, or we can address it using the actual name of the value we're looking for. If we're going to address using the key, we'll need to use an ampersand to tell MDX, hey, this is the key and not the actual value associated with it. We'll see examples of that shortly. And speaking of shortly, that time is now. So we're going to jump into the demos. Again, for those of you who came in late, all of the samples are already uploaded to bit.ly, so you think MDX is hard, all one word. All right, so let me jump over here. And here we are inside of SQL Server Management Studio. Now, in the download file, I include a PDF of the slides. I also included a backup of the database that I am querying against. To restore that backup, you'll just right-click on your analysis services connection, go into the database, and click on Restore. And then in my restoration, which of course comes over here in my other monitor, you'll just go into the backup file, click Browse, go to that ABF file, and then restore it. It will then show up here after you do a refresh. It'll show up here in the list. Now, one thing, I've named the database AdventureWorks DW 2015, but inside the cube is still called AdventureWorks DW 2014 because I created the cube last year. Haven't gotten around to renaming it yet. So a few housekeeping things. Here we are inside of our MDX script. And over here on the left, you can see I have my little navigation pane. So I can quickly drill in and see what measures I have. I can look at my products. I can drill down actually and look at the values associated with these. So you can actually take these then and do some dragging and dropping over here to make life a little easier for you. Also, a few things. Within MDX, we'll see here that the double slash is the official way of doing an MDX comment. Now, SQL Server supports the double dash format, just like it does in T-SQL. Not all MDX interpreters, though, support that. So you might just want to get into the habit of just using the double slash when you're in here. The same slash asterisk syntax that is used in T-SQL is also supported here for doing multi-line comments. Okay, so we're going to start with the most basic of MDX queries, and that is getting a single cell back from our cube. So you can see here, let me smidge bigger, I have the absolute simplest item, select from AdventureWorks DW 2014. And we'll execute this, and you'll see it brings me back a value, 6,127,869. Now, you may wonder, well, what in the world did that number is? Where did it come from? Well, if you go in Designer, I won't do that right now for lack of time, but if you go over to Visual Studio and open up your Cube Designer, one of the properties for the cube is called default measure. And that default measure says, well, what do you return if somebody says, give me something from the cube, it doesn't specify what? Now, you can fill that in. If you don't, it just takes whatever the very first measure it encounters in the cube. So here we go. I'm going to show you that what I'm actually getting is my internet order quantity. And I'm doing so by specifying it in the where clause. Now, one of the things that generally throws people is the where clause, because the where clause doesn't act like the filter it does inside T-SQL. In T-SQL, it's used to limit what you bring back, and here it kind of does that. What we're basically saying here is, I want you to bring back a value from the cube where that value is in the internet order quantity. If I scroll down here, we can actually extend our value in the where clause to say, I want you to bring back a value from the cube where that value is the internet total product cost for my product category bytes. So what I've done here is I've actually created a tuple. Here is the first parenthesis, and then I've just listed each item in the tuple. I've given it enough items to uniquely identify the cell in the cube that I want. Up here, this is actually a tuple too. Even though it's only one item, it is indeed a tuple. So let's expand this tuple out to 3 dimensions. I'm going to run this. And we see here, by now adding a third item, I'm saying I want the internet total product cost for bikes for the sales territory of Europe. Now, remember earlier we were talking about keys. And you'll notice here I used ampersand and then the word Europe. Well, you won't see this all that often. Occasionally I do see this. When you have an item that is not at the lowest level of granularity, then the key and the name will be the same thing. If I come over here, I'm going to come to the sales territory, and you can see that I have a territory hierarchy which consists of group, country, and region. Well, my group is where Europe sits, so it is much higher than the lowest level of granularity, which is region. So there's no specific surrogate key associated with this member inside my sales territory dimensions. Because of that, if I want to reference it by key, the key and the name are the same thing. And so you can see down here, if I actually run the same query and just omit the ampersand, I get the exact same value back. So in the case where you see an ampersand and a number, that's probably referencing a surrogate key. If you see an ampersand in text, that should be a clear indicator that this item is not at my lowest level of granularity. It's not specifically unique. It's at a higher level, such as we have here with Europe being fairly high up in my hierarchy. Okay, so far I have used MDX to get back a specific cell. Now I actually want to return back, I guess you could call them a set of cells or a group of cells. And I'm going to do so by moving my item I want to get, internet total product cost, and I'm going to add a clause up here called on columns. So I've taken this out of the where, I've moved it up into the select, and then I've added the keyword on columns. Now, you're going to see I'm still getting back a single value, but if you notice right here, it says internet total product, and if I expand this out, it would say product cost, and it returns the value. Now let's contrast this where we're putting it back down here in the where clause, and you can see I lack the header. So the difference is this is bringing me back a single cell and will only have a single cell. The previous one, the on columns, actually brings me back one or more cells in my result set. I can also bring back multiple rows and columns. Here you can see I still have my internet total product cost on the columns, but now I'm adding in the product categories on the rows. And so you can see here what it's done is it says, well, first give me back the internet total product cost for everything, then give me back the internet total product cost for bikes, components, clothing, and so forth, and it lays them out on this nice little grid for you. The other thing to notice is this little dot members out here. This is a function in MDX, and what it says is, I want you to go to the product. So let's go over here on the left to my little browser. We're going to go to the product. Now I want you to go to the category. So we're going to come here to categories. And now I want you to give me all of the members. So what it says is, okay, first give me bikes, components, clothing, and so forth. So this is a nice little shortcut for you, because rather than actually having to type in product.category.bikes, product.category.components, and so forth, this actually then takes care of it for you on the fly. This is also nice because if your list of categories were to change, MDX will automatically reconcile that for you. Okay. We can actually create a nifty little pivot chart by using tuples on both the rows and the columns. So let me run this. And what you can see is I've said, well, I want you to give me the internet total product cost and do it for each year. In other words, each member in my year dimension. And then on the rows, I want you to break out my product categories members. So here you can see all 2005, 2006, 2007. So I'm getting a nifty little pivot chart effect out of this. You can reverse the order in which you list things. So for example, here, I'm putting rows first, and then I'm putting my columns second. So MDX isn't real picky about the order in which you want to list things. Obviously, it's easier if you keep up your columns and your rows, but it's not absolutely necessary. I do want to show you, though, that it is important to list things in the correct order, or to include things. For example, here, I'm just saying select product category members on rows. Well, if I run this, it's actually going to give me this nifty little red error. And what it's really saying is that you can't have rows without having categories. So you always have to have rows without having columns. You always have to have columns, and before you can have, after columns, now you can add rows. There is a way to kind of trick this. Let's say you wanted to get back a list of your product category members to use inside, maybe you're writing a reporting services report, and you've got a drop-down that you want to use for your parameters. There is a little trick you can use, which is supplying an empty set. If you remember in our earlier discussion, we're going to come back to sets momentarily, but a set is multiple items from the same dimension, but an empty set can actually be used to say, don't give me anything here. So here I'm using an empty set, and it's just going to bring back my list of all bikes, components, and so forth. So this is a nifty little trick you can do if you're using reporting services. But what if we actually want to use the set to bring back multiple items? Well, to do so, we just simply list the items we want. So here you can see I have my squiggly race and my internet total product cost for my measures dimension. And now I've said I want another item from that same dimension, the internet sales amount. So we simply list comma, list the next item, close out the set with our squiggly race. And we're going to stick that on the columns. And then it's our good old product category members on the rows. And you can see here in the results, I have listed for each product category. I now have the two measures side by side in my output. Now, one of the things you may have noticed, if you look at the line for components and for unknown, they are all null. There's no values in there. And so we'd really like to eliminate those from the results set. Well, there is a keyword called non-empty. And what that simply means is when you get back this data, I want you to strip out all the rows that are empty. In other words, only give me the rows that are not empty. So here we go. Let's run this. Now you're going to see that my empty cells are now gone. Now, one of the rules is that in order for this to work, all of the cells on that particular row must be empty in order to be suppressed. So if I had an empty in the left-hand column, but I had a value in the right, that row would still be included. Yes, the recording will be available afterwards. I want to point out something real quick. Non-empty is the last thing that gets done in the result set, and that's going to come into play in a little bit. We can do more. Here I am combining my rows and measures with a where clause. So what this is going to do is it's going to take that same query we just did, the internet product cost and sales amount, with the non-empty, but it's going to say, I want you to limit this for just the sales territory of Europe. Now, because the sales territory of Europe is in the where clause, it's not going to appear anywhere in the result set. So you don't see Europe appearing anywhere down that little grid pane at the bottom. However, it still is limited the data for just Europe. Now, we can go further, and what we're going to do is create kind of a complex tuple in that we're going to combine two sets on the columns. So here I am taking the order date, year, members. Now, what members, you got to remember, what members actually does is it decomposes this into a set with each year being a member. So order date.year.2005, order date.year.2006, and so forth. And then it's going to take that set and combine it with my Internet Total Product Cost Sales Amount set, and it's going to put that on the columns. And so let's go run this, and you can see where it works with this little combination as well. And you can see down here we have all 2005 Internet Product Cost, Internet Sales Amount, 2006, and so forth. Now, out here on the right, you're going to notice that I do have some null columns out here. Now, even though we put non-empty on the rows, well, this row here, clothing, there's data in here. There's $30,000 for 2015, and there's another $2 million for the sales amount. So we can't suppress these rows because these actually have data in it. But non-empty will work on columns as well. So you can see here, I have select non-empty moved up to my columns, and I have it on my rows as well. And that's the only difference in this query. But now, if I scroll out here to the right, you can see all of my empty columns have gone away. So with this, again, if all of the rows inside of a column are empty, it will suppress that column. Alrighty. We've already mentioned where it can contain a tuple. Here I've got sales territory Europe for the year 2013. I won't run this right now at a time, but the where has always been a tuple. So I wanted to show you here something very important. Now, I've been mentioning that all is a stored value. So what I'm doing here is I am creating a set for product category accessories, product category clothing, and all. Essentially, I'm omitting the bikes category from my result set. When I run this, you're going to see some interesting numbers. Now, for our Internet Total Product Cost, we have accessory value of $3.89 million and clothing of $3.04 million. So grand total of just under $7 million. My all value, though, shows up as $216 million. So all, even though we're only displaying accessories and clothing above it, all is still the all value. This is something to be careful of because a lot of people new to this will come back and think that, well, if I include all, it only shows me like a grand total for what I see on the screen. And that's not the case. All is actually stored in the cube. Here I wanted to show you something. So in this query, I'm going to run my product.color, and over here on the left we can see our color. And if I drill down into color, and if I drill down into members, you're going to see all, black, blue, gray, multi, and so forth. And so that's what we have here, all, black, blue, multi, and so forth. What if we wanted to write a query, though, that returned everything except all? There's a lot of reasons we might want to do this. Maybe I'm trying to do some grand total type reporting, and I want to exclude all. Well, we can do this through something it calls, the MDX calls the level function. And let me just run this. And what you're going to notice that's different about this query versus the previous one is that I say product.color.color.members. When I repeat the name of that attribute, what it's doing is it's drilling all the way down past all to the slightly lower level, and it's just returning that. So over here on the left, you can actually see this. Here you can see I have product.color, and I have its members. But down here under it, you can see I have the color again. If I expand it, you can see it excludes all, but it does include all of my other colors. So that's what happens is when we see the all, you can see it actually drills down to this level here and not the higher up level. So again, let's go run this query one more time. And in this case, for our product category, we're using the level function, product.category.category, to create our pivot table. And so here we have 2005 Internet Product Cost, Internet Sales Amount. We've excluded all out of the result set. So just remember that if you are in a situation where you don't want all, you need to use the level function, which just basically repeats the name of the attribute that you're using. Now, typically all appears as the first item, but we can actually do some interesting trickery here with sets. So in this line, I'm creating a new set. There's a little squiggly brace that says the set's coming, and I'm getting back multiple items from the same dimension, product category dimension. So the first thing I do is I use the level function to get all the members of the product category except for all. And then I'm specifically referencing the all category here, and it's going to create a combined set for me, but all will be at the bottom. So here we go, bikes, clothing, accessories, and all. So if you wanted to write a little query that made it look like you're doing a grand total, as long as you knew that you weren't going to exclude some members from the set, you can actually do that by using this little all at the end trick. We'll skip over this example. There's a lot of lines to this script. There's probably more than we're going to have time to go through in this session, but they are well documented. So as you run through this at home or in your office place, you can easily step through these examples and be able to understand what's going on. So we already did that one earlier. There's some cool MDX functions we have. We've already talked about the member function. We also have another function called children. And what children does is it says, give me all the children under this level of the hierarchy. So here over in my product.products, because I don't specify a specific level of my hierarchy, it returns me all the members at the top level. Well, the top level is category, so it returns me all the children of the top level category, bikes, clothing, and accessories. We can also drill down to a specific member and get all of the children of that specific member. So here I have gone down to my product category to the specific member bikes, and its children are mountain bikes, road bikes, and touring bikes. So again, we're seeing, and this is actually a fairly useful function. If you're doing a report that maybe kind of lets you drill in, this can be a very useful function. Now, there is one little trick that I'll see some people do, and it always kind of makes me cringe, because you can actually omit some levels of a hierarchy if that particular value you're going after is unique. So in this particular case, you can see I'm saying product.mountainbikes.children on rows. And this will actually work, and that's because we know that the mountain bikes is unique, and it falls into the product.products.subcategory range. The problem is, what happens tomorrow if we create another mountain bikes, instead of under the bikes category, we now have a second one under accessories. Well, now all of a sudden your query breaks because mountain bikes is no longer unique. So where possible, don't use this little shortcut. Always spell out the full name. That way there's no ambiguity to people who come along after you and work with your queries. All right. Just like we have children, we can have parents. So in this particular example, I'm just saying, give me the parent of the mountain bike, which is bikes. This is a function that, honestly, I don't use a whole lot. But I just want to point out, you can have children, you can have parents. In most cubes, you're going to run into situations where you have something called a composite key. Most commonly, these are coming from dates. So in this particular calendar hierarchy for my date dimension, I said the quarter attribute had a key of the year plus the year number plus the quarter number, so 2013 and 3. So to reference that, I simply use the ampersand, give it the numeric value for year, and then I just string on another ampersand and unique value for the quarter number, and that's how I can get this. So here I'm getting the 2013 3 parent, which gives me the year 2013. So again, you just string these together just one after the other for any composite keys. Pretty straightforward. Another cool thing about MDX that is very, very difficult to do in, say, T-SQL is that I can actually create a query that mixes items from multiple levels. So here, I've got another query. And first you'll note in this particular calendar, I've got it called calendar detail. It uses a slightly different unique value for my quarter year, and that's just a single number for my key. So don't let that fool you. This is a different calendar with a different hierarchy. So I'm combining the parent of that with the children of it with that value itself. So I've created a set that encompasses 3 different levels of my hierarchy. And down here at the bottom, you can see 2013. So there's the first one. There's the parent. And then I have the children of that quarter, so July, August, and September. And then I have that quarter itself, Q3 2013. So it is easily possible to mix and match data from multiple levels. In addition to parents and children, we can also have cousins. I'm from Alabama, so we call them kissing cousins. And here in the cousin, what I'm saying is, for this specific level of a hierarchy, I want you to get me the same level, but from a different branch of the hierarchy. So what this is saying is, for the third quarter of 2013, so it's the third member in the 2013 quarter year, I want you to go give me that same attribute, but for the year branch of 2012. Okay, so this is just a way that you can get a parallel item. This would be a good way to go get same quarter last year, for example. All right. Here, I think we've kind of shown this before. I've got a tuple where I've got 2 sets, and I'm mixing the multiple level sets plus my product members. We won't take time to run that. Previous member. One of the things I'd like to be able to do is get the previous member of a particular attribute. So here, I have a set that the very first item in the set says, for the year quarter of 2013-03, third quarter, I want you to give me the previous member, which is going to be the second quarter of 2013. Well, what if I want to get the member before that, if I want to go back to? Well, yeah, you can see here, I can actually stack up pre-member.pre-member. But imagine if you wanted to go back a whole bunch, this would get kind of redundant after a while. So MDX includes a function called lag. And lag just says, well, give me the number of units you want me to go back. So in this case, I want to go back 3 members, which is going to take me back to the final quarter of the previous year. So let's run this just so you can see the output. And so going back 1 quarter from 2013-03 gives me back Q2. The .premember.premember goes back 2 quarters. Then using lag 3 goes back 3. So there's Q4 2013. So again, pre-member is good if you know you're only going back 1. If you want to go back more than 1, use lag. Now what if you want to go into the future? Well, you can simply lag with a negative value. So here I'm saying I want you to lag -3, which is going to take me 3 quarters into the future. So Q2 2014. But, you know, using negative values into the lag function is sort of like using a double negative in the English language. You don't not ought to do it. So for that, MDX has a function called read, which works exactly the same as the lag with a negative value. It's just much easier to read. So if you want to go into the future, use read. If you're going into the past, use lag. Okay. So one of the things people often wonder is, how can I reorder the output? Typically, output comes in the order in which things are saved in the database. So for a calendar detail year, it's going to start with the first year. In this database, it's 2005. And it's just going to go forward 2006, 2007, 2008. What if I want to, though, instead of going it by year, I want to get that same year, but I want to order it by the internet sales amount. So there is a function in MDX called order. And with order, you first say, this is the set that I want you to sort, the calendar year members. And the second parameter is, how do I want you to sort it? Well, I want to sort it based on the internet sales amount. And then finally, I indicate either ASC for ascending order or DESC for descending order. Now, typically, what you're going to do is you're going to order it by the same measure you're displaying on the columns, but that's not absolutely necessary. You could measure it, you could sort it by, whatever you want to use for the order. So here you can see we start with my biggest internet sales amount was the year 2011, 2007, 2008, and so forth. Now we're all sorted nicely by the values. So here's 2015. Things aren't looking real good this year, but we're only halfway through the year, 71 million. So this is how you can reorder things simply by using the order function. Now, things can get kind of tricky when you want to order and you're using a hierarchy. And I generally recommend you don't try to do this because often it doesn't make any sense. But, first thing we get into is all. All is always going to be first. And so the next thing I say is, well, I'm using the ship date.calendar detail, which is actually a hierarchy that's year, month, year, quarter, month, day. And so it's going to go through each member and it's going to say, well, 2011 was my biggest, so it's going to come first. Then it's going to say, okay, within 2011, the next level down was quarter, so what's my biggest quarter? Well, that's Q2 2011. Okay, so within Q2 2011, which was my biggest one? Well, that would be May. Okay, within May, which was my biggest one? And we keep drilling down to the individual dates. And then down here you can see, okay, well, May was the biggest one in that quarter. What's the next month? Well, that's June. And so you can see here, it gets kind of confusing, kind of hard to read when you use this thing with a hierarchy. So I generally recommend you don't do it. There is, though, one other function in here. There's a parameter you can pass into the order. You'll see it's called DESC. And what that means basically is break hierarchies and put them in descending order. So now you can see I have my all, then I have the years, and then I have the quarters, and that is actually a year for 2015 that actually has less money than one of the quarters. And so then we'll eventually get down to days. So this is a way that you can actually break the ordering in which things would occur within a hierarchy. Again, I don't recommend you use order with a hierarchy because it just doesn't make sense most of the time. A lot of people ask me, how do I do a top 10 or a top 5? Well, I can do so through a top count function. With top count, you simply pass in the set, in this case my product members. I want the first 5 of them, and I want that based on the internet sales amount. So that's all there is to top count. The set that you want to sort, how many do you want back, and what do you want to do it by? Let's come down here. There's also a top percent. So here, I'm basically getting the top 25% of my items. In this case, it's the product members. Now, there is a bottom count function. If I run this, though, bottom count is just going to return me a bunch of nulls. Well, you might think we can use non-empty. And if I run this, what's going to happen is we actually get back nothing. If you remember earlier, I made the statement that non-empty filters out the rows after the result set comes back. So I get a result set full of nulls, and then bottom count then filters out all the empty ones from that all null roll set, and you get nothing. To fix that, there is a non-empty function, and that is non-empty with no space in it. And what that says is, okay, I first want you to take a set of product category members, and I want you to toss out all the ones that are null. So the resultant of non-empty will say, take all the product members that have an internet sales amount value. Then take this set, pass it into bottom count for the bottom 5 based on the internet sales amount. And that gives me my bottom 5 that actually have values in it. Likewise, there's a bottom percent that works exactly the same way. We're going to use our non-empty function to make him work. All right, something you're going to hear talked about a lot is cross joins. We have said a set is multiple items from the same dimensions of my calendars with my product category members. So to do that, we have a function called cross join, and you just pass in the two. So here we go. We're getting the years and the product categories. And you can see down in the left-hand column. Yeah, sorry about the audio. If anybody else is having problems. Over on the left, we have the years, and then we have the bikes, clothing categories, and so forth. Now, there's a shortcut for that you're going to see, and that is simply an asterisk in here. So here I've got order date, calendar year, asterisk product members, and we're going to get back the exact same result set. So asterisk can be a great shortcut, and it's really nice because if I wanted to cross-join 3 sets, to use the cross-join function multiple times, you see I've got to use cross-join, cross-join. With the asterisk shortcut, I simply just say set 1, asterisk set 2, asterisk set 3, and I can have asterisk set 4, asterisk set 5, and so forth. So you're going to see this asterisk syntax quite a bit. Year-to-date, it's a very common query that people want to see run. The year-to-date function, though, doesn't work quite like you think. What it does is you give it a specific member of your calendar hierarchy, and it gives you those individual totals for each slice up to that member. So in this case, as I say quarter, it's going to give me each quarter up to that. So we're going to see how to work with this in a little while to actually get a grand total for the year. Let me just skip over this because I want to show you calculations. One of the main purposes for understanding MDX in this environment is to be able to do calculations. So we're going to create a calculated member by using a with clause. Because, you know, when you're trying to develop calculations inside Visual Studio, what happens? You create the calculation, then you got to deploy the cube, and then you go test, and then got to redo the whole thing. They can become quite time-consuming. So by learning all the MDX we've learned so far, you can actually use this to create calculated values here, and then cut and paste those calculations into Visual Studio with a high assurance that it's going to work right. I always start my calculations, though, by creating a null value. So to start creating calculated members, you start with the with clause, and then you can do one or more members. So member says, this is a new member I want you to add. We're going to call this one profit. As indicates here comes the calculation. In this case, I'm just saying null. I then have my select statement, and you can see I'm including the profit. And when I run this, I'm going to get null back in my column. But the advantage to this is I now know my select statement is going to function correctly. So if I run this again after working on it and the query doesn't work, I know I can focus on just that calculated member. I know the rest of the query functions correctly. So now I'm going to add something to this. I'm going to say, well, it's my internet sales amount minus my total product cost. So again, I'll run this. And I get back a profit value. But, you know, I'd really like to see this as a percentage. So I'm going to further expand my member calculation to take my subtracted value and then divide it by my internet sales amount. So when I run this, I get a value back, 0.899, 0.818, and so forth. let's make this a little prettier though, because I actually want to see this formatted as a percentage. So there is a clause we can add to our calculation. After the calculation, I put in a comma, and then I have format underbar string equals, and in this case, I can use a value that MDX understands called percent. I could have also have typed in something like 0.00%, or just 0% if I wanted to eliminate any decimal places. And so now we're going to get a nicely formatted value out of here. So this can be a way that you can actually see what is this going to look like to my end user. Now, I can hear you going, geez, Robert, you're awful reckless. What if my internet sales amount is 0? You're going to divide by 0 and destroy the universe. No, it's very easy to actually take care of this. There's another MDX function called IIF, which is a simple if statement. And in this, we're going to use another new function called isEmpty. And isEmpty just says, well, if this is empty, in other words, if there's a null in it, or if that value is 0, and then this first guy is then, I want you to return null, and the next comment is else, I want you to actually do the calculation. Now, I don't have any in here that are null, so this doesn't, I'm not going to really show you anything, but that is the proper way to filter out for nulls. I can include multiple members within my calculation, so here's with, then I have the first member, which is my sales difference, and then the second member is the sales difference divided by my internet sales amount. Now, this has many distinct advantages to doing this, and it's very common to break your calculations into small pieces. First off, it makes it much easier to debug because I can actually include these various members in my output. So you can see here I've added my sales diff and my profit. I can, in Visual Studio, though, if I want to, there's a visible property. I can say, well, I want you to include this, but hide it from the end user. So you could actually successfully do these kind of things. The other thing, though, I wanted to mention about this is if you have multiple members and you are referencing a member, in this case sales difference, inside this calculation member, the one I am referencing has to come first or prior to it. So sales diff must occur before by definition of profit. All right. Let's see. I think we're about out of time. I'll show you one thing real quick. It's also possible to do sets. Let me just jump down here to sets. And essentially what I can do is I can create a name set. So under my with statement here, you can see I have a with, and I just left that member calculation in there. I defined a set called top 10 products. I define it as my top count function. And then here I can actually use that set in my rows function. I can also use it on columns. And this gives me a nice shortcut for creating a set that I can store in my cube and then make that available to users to run over and over. Okay, so with our last few minutes left, we'll see if there are any questions. I don't see any in the chat window. All right, since I don't see any questions coming up, I'll just, let's see. Oh,
hey, Robert, there's actually some over there in the
here.
questions window if you want to go take a look.
Yeah, I apologize. The questions window got kind of buried. So let's see what we have here. And if I don't, obviously I probably won't have time to get to all of these, but we'll create a blog post that kind of goes through these. Let me just come back up here to the front. So null is basically treated like a 0 in a row that is empty. Kind of, it is thrown out for some calculations. So if I'm creating an average, let's say, null won't be included in the total count for the average. Yeah, is it possible to select all members but exclude specific items? Yes, there is a function called accept, E-X-C-E-P-T, and what you can do is you could say something like select product.members accept product.bikes. Okay, so I already talked about non-empty versus non-empty. One with space, yes, they are different. We explained that, hopefully. Is the main advantage of the query syntax writing speed, or yeah, it's not so much the writing speed, although that is quite nice. It is the fact that MDX has actually calculated a bunch of these totals ahead of time. Like the all value, for example, or if you have properly defined your cube, it will also store aggregated values, say, at each member of a hierarchy. So here, it knows that subcategory is a total of all the products under it, and it knows that category is all the subcategories. So for example, if I wanted bikes, it knows that I only have to go add up 3 numbers, the 3 different subcategory bikes, to get back that total. I don't actually have to go all the way down to the thousands of bicycles that I actually have. Let me expand this question a little bit just so I can see a little more space. Difference between members and children. Members brings back all of the values at a particular level. So if I want to bring back the members of category, it's going to bring me back bikes, clothing, components, and so forth. If I want to bring back the children of something, if I say children of bikes, what it's going to do is it's going to go into the subcategory, and it's going to say, show me all of these subcategory items associated with my bikes category. So that's the main difference. Yes, the question was, can you sort by a dimensional attribute? The answer to that is yes. Okay, we'll go back to the previous year calculation here in just a second if we have a minute left. But if not, there is an example inside the sample downloads that talks about how to do previous year calculations. Will this work with the 2012 version? Actually, yes, indeed. This actually is 2012. I'm using the SQL Server 2014 browser, but this is actually a SQL Server 2012 database. So be aware that if you're running on an older version of SSAS, this may or may not work. Although to be honest, there have been almost no changes with multidimensional analysis services since 2008 R2. So I have actually used the SQL Server 2008 R2 browser to hook to a SQL Server 2012 database, and it worked just fine. That's just because there's almost little or no changes between the 2008 R2, 2012, and 2014. What's the difference between a query MDX beginning with select and with? What the with does is it's just the way I define the calculation. So the with statement says, hey, there's some calculations coming, and then when I hit the select statement, it knows the calculations are over. It's now time to do other stuff. Question about the scope function. I don't think I have an example in here, but what the scope function does is when you place this in your calculation sections, scope says, I want to replace this particular item you're looking for with something else. So, for example, I see this used a lot with December. Well, let's say I am getting the internet sales for December because I'm going to use that for forecast. Well, for each month, I can probably take the previous year's value and do that, maybe take an average of it. But if I'm getting December, instead of the default calculation, I want to replace it with a special calculation. Maybe I want to multiply it by 1.5 because I know my sales in September should be higher. So I can do things like that with the scope function. I can replace the value of a specific cell and instead say, well, if you encounter something for that specific cell, instead I want you to replace it with whatever I have inside the scope. One of my coworkers, SQL Dusty, at SQL Dusty, has a really good article on scope on his blog. So let's see. I think we're right at our time limit, so I'll go through these, and the ones I didn't get a chance to answer, we will see about doing some blog posts on. All right.
Thanks, Robert. We will have the recording of this up on our website shortly, so be sure to check out our Facebook and our Twitter, because we'll be sure to let you know when it's up. Give us a follow, and then Robert will work together to put together a blog post of some of the best questions that we received. Thank you, everybody, and have a fantastic day.